this page with a stress of being concentration. So when we take a look at example number 3, our stress is the NH3, it's been removed, and we identified the system shifts to the left. So now why? So now there's not enough NH3. So now there's not enough NH3. And so now the system needs to replace it. Well, how does the system replace it? By shifting towards it. So when we shift, whatever we shift towards, that's what we're making. So in this case, because NH3 is a reactant, the system shifts left towards it. So that means that the reverse reaction is favored. That the products are going to make a little bit more of the reactants. Well, how does it do it? The products, NO and H2O, have to react endothermically. So the products react endothermically. So if they are reacting, that means that they're being used. So the concentration of NO and H2O is both are going to decrease because they are being used in the reverse reaction. If it's endothermically, the heat is being absorbed during the process. So I'm going to write endo here. The system is going to feel cooler because endothermically that heat energy is being pulled into the new bonds, okay, and stored. So the amount of heat that's available to the system has decreased. And as the products react endothermically, they make more of the reactants. So on the reactant side, O2 is there, so the O2 concentration is going to increase, and now the NH3, it's going to be replaced. So the purpose of shifting is to replace, so being replaced. And let's look at our last example here. So NO was the stress. Some of it was taken out, and we identified, since the stress is a product, the system is going to shift towards that, and so the system shifts right. So now there's not enough NO. So there's not enough of the nitrogen monoxide in the system. So let me write that correctly. So there's not enough NO in the system has to replace. And the way the system replaces it is by favoring the forward reaction. So the forward reaction is favored, meaning that the reactants are going to be used to make some more of the stuff on the product side in order to replace this. So the reactants, which are NH3 and O2, they react exothermically. So if they are reacting, that means that they're being used. So their individual concentrations are going to be decreased. But remember, the N, the H, and the O, those elements don't disappear from the system. We see them as in their new partnerships in the products, the formulas on the product side. So the reactants react exothermically to form more of the products. So that means that the H2O, more H2O is going to be formed, so its concentration is going to increase. The NO is now going to be replaced. And because it is reacting exothermically, that means that heat has been released. So if you touch the closed system, like the the container, it's going to feel warmer because now there's an increase in the heat that's moving around in the system.